So this is a table question. A mass of 12 kg rests on a rough horizontal table. Let's just do a quick sketch. Here's my 12. And then going across and over this pulley. And the same on this side. There are two other weights hanging freely. And they weigh 10 and 4. And it doesn't matter which way you put them. The coefficient of friction between the 12 and the table. So we have here mu for the coefficient of friction, and we're told that if mu is a quarter, show the acceleration will be this. So we'll just go about the question the normal way, find acceleration with mu being a quarter. So let's do our equations. 4, what direction is it going? Let's say it's going up. So mg, call me strings 1 and 2. So I have my T1 minus 4g is equal to 4a. For the 10, it's going down. 10g T2. So for the 10, I have 10g minus T2 equals ma, which is 10a. And now for the 12, a couple of things going on. I have my OR. Let me just move it down a little bit. Do my table. My T2. T1. Put my mu OR here. OR. And mg 12g. So my reaction OR is equal to 12g. So mu OR is equal to a quarter times 12g, which is equal to 3g. So my equation now is T2, it's going in this direction, T2 minus T1 minus mu OR, which has just got to be 3g, is equal to ma, which is 12a. Bringing our other two equations down, T1 minus 4g is equal to 4a, and 10g minus T2 is equal to 10a. Combining all three equations, we're going to get 10 minus 7, which is 3g, is equal to 16 and 10, 26a. So a is 3g over 26 meters per second squared. And then you go back up and you go, hopefully, that's what they asked us to show, 3 over 26 times g, which I like writing as 3g over 26, but they're the same thing. What is the least value of what's the least value of mu for which the particles will not move? So for the particles not to move, acceleration has to be 0. So what has changed for the particles not to move? Well, this mu in here, this quarter is going to change. So everything else stays the same. So the 3g came from 12g times a quarter, but 12g times mu. So if we just change that quarter to a mu, or change this 3g to 12g mu, we should be able to get a value for a, and that we can let equal 0, and hopefully that will solve down to give us a value for mu. So we're going to have T2 minus T1 minus 12g mu equals 12a. We're going to have T1 minus 4g equals 4a, and minus T2 plus 10g is equal to 10a. Are we going in the right direction? So we're going to have 6g minus 12g mu is equal to 16 and 12. Sorry, 14 and 12, 26a. So I can factor out 6g out of the left here. Will that help me? Not sure. 6g times 1 minus 2 mu. Well, there we have mu is equal to 26a. So I want a on my own. So actually, I'm just going to bring that 26 underneath here and just cross it off here. So that's what a is equal to. So for this whole thing to be equal to 0, we can say the top line has to be equal to 0. So 6g times 1 minus 2 mu would have to be equal to 0, which means that 1 minus 2 mu would have to be equal to 0, leaving 2 mu equal to 1. So mu is equal to half the minimum value of mu, for which they won't move. Okay, what else have we got here? 10 and 11. Question 10. The diagram shows particles of 2 and 3, and we've different strings going on here. We've T1, T2. They're connected by the string, edge of the table, 3 kilogram connected to another 3 kilogram, and the contact between the particles and the table is, and the coefficient of friction is a quarter. Don't go over it, just here a quarter. Okay, let's look at our diagrams. Let's start with the 2 kilo. So there is mu, we have or, we have mg, and we have a string which we called T1. And we can say it's going in this direction. So or is equal to 2g. So mu or is equal to 2g by a quarter, which is equal to g over 2. So my equation, T1 minus mu or, which is g over 2, is equal to ma, or 2a. We move on to the 3 kilo, that's on the table. Again, we're going to have mu or, we're going to have T2, we're going to have T1. This is a different reaction here. I'll call this one, it's not the same or, so I'll call this one, call it R2. We used R1, but I'll call it R2. And I have, this is this block here we're dealing with, 3, so MA, sorry, MG, 3G. Let's put a 2 in here, or 2. So or 2 is equal to 3G. So mu or 2 is equal to 3G by a quarter, or 3G over 4. So my equation, it's going in this direction. So I'm going to have T2 minus T1 minus mu or 2, 3G over 4 is equal to MA, 3A. And then moving on to my 3 kilo, I'm just going to put a box around these. You can number your equations if you want. I'll call them A, B, and C, whatever you choose. So this is going down in this direction. It's attached to string 2. I have mg, 3g. So my equation is 3g minus T2 is equal to MA, or 3A. So if we combine these three equations, T2 minus T1 minus 3g over 4 is equal to 3a. We up above, T1 minus g over 2 is equal to 2a, and we have minus T2 plus 3g equals 3a. So if we combine these, we're going to get 3g. I'll just write a little bit of rough work here. We're going to get 3. I'll just do the numbers. 3. The one above it is a half. to minus a half, this one here, and above that minus 3/4. So that's 3 minus 1.25, which is 1.75, or 1 3/4, or 7/4. So I'm going to have 7g over 4 is equal to 6 and 2, 8a. So 7g over 4/8, 32, is equal to a. And that's in meters per second squared, or ms to the minus 2. Is there another part? Question 10. The tension in the string. Okay, an easy equation for T1 and T2. Take the shorter ones. T1 is equal to 2a plus g over 2. So T1 is equal to, so that's going to be twice 7g over 32, or 14g over 32, plus half, so that's 16g over 32. So that's going to give me 30g over 32, which can be simplified down to 15g over 16. And T2 up here, T2, if I bring it to the right, is equal to 3g minus 3a, which is 3. Actually, they want it in terms of g here. Let's do this. 3g minus 3 times this acceleration is 3 7ths 21 g over 32. So I have 96 g over 32. That's my 3g minus 21 of them. It's going to give me 75 g over 32.